So, Professor Edward Smith, can you tell us, this year's Nobel winner, what is their significance of their discovery?
Well, people have been trying to develop immunotherapy for tumors for 150 years. Already back in the 19th century, in the middle of 19th century, people were doing this. And there have been so many disappointments over the years. The important thing has been that there's been a lot of good basic research, so there's much more knowledge about how different cells function. And this has really been the basis for this year's discoveries. Without this basic knowledge about how T lymphocytes recognize foreign entities, it would not have been possible to develop the methods that are used now. So it's really a major breakthrough, especially because these cells, you can release these cells to start to kill different types of tumors. Most previous tumor treatments were very much directed towards a particular tumor, but this treatment is directing against many tumors.
So my understanding seems to be opposite. So you mean this time, or this inhibition discovery actually can kill many different kinds of cancer?
Yes, very much so. The first cancers that were studied were malignant melanoma, which of course is a very severe disease, where very few people survived even 6-8 months.
Which part of the body?
So this is a cutaneous tumor, but it grows invasively, so it gives metastasis in the brain and in different parts. Later, but just very shortly, later it was shown that this therapy works in lung cancer. It works, for instance, quite well in smoking-induced lung cancer. It works also particularly well in sunshine-induced malignant melanoma. And both of these have to do with the fact that both the sunlight and the tobacco smoking induces a lot of mutations, changes in the genes of the cancer cells. The more changes there are in the cancer cell, the more is there for the immune system to recognize. It works also in many other cancers, liver cancer, renal cancer, several different cancer types, but not all. There are still cancers like pancreatic cancer where it does not work.
So you mean this sunlight, you mean like skin cancer?
Yes, so it's quite well known that if you expose yourself to a lot of sunshine, this is known very well from Australia, for instance, where there is a high frequency of skin cancers. And those types of skin cancers that are induced by sunlight, they are particularly sensitive to this kind of treatment.
And is it, so this is a treatment process, it's not a checking or diagnose
No,
process.
it's about a new treatment. So the checkpoint, you can say, the name checkpoint, which is immune checkpoint, means that in T lymphocytes there are different regulators. There is one way to recognize something which is foreign, the tumor cell, for instance. There is another signaling pathway which tells the cell to really go and try and kill it. But when that has happened, there is a break which prevents this process from going on. The reason the break exists has to do with that without the break there is a risk that the body's immune system tries to kill the body itself, what's called autoimmunity. So this is why you have this kind of breaks to prevent this from happening. But
so this break point actually exists in your body?
Yes, so always when you have, let's say, an infection, the immune system will start to kill off infected cells, but there are the breaks that limit the response. And the same thing is true for tumors, that the immune system may recognize the tumor, but will not really do anything about it, because the breaks are there and prevents it from doing that. So what Axelsson realized was that if you take away the break, then there should possibly be the case that the immune system now can kill tumor cells. And this was so nicely demonstrated by Tasco-Honjo, that by using another break, which is even more powerful than the one that Axelsson found and discovered, you can have even stronger effects. So the latest development in Tascohongu's laboratory with PD-1 and PD-L1 has really shown that these are extremely powerful brakes. If you take them away, you get a really nice response to the tumor. And interestingly, and somewhat unexpectedly, you do not see very strong autoimmune reactions when you take away the PD-1 and the PD-L1 brakes.
How many
sorry,
people
but
you?
we're on it. No, but you're not supposed
how
to be.
many?
You're not on the list for this person, and we've been.
How many
waiting
people
now.
you think this will benefit in future?
In the long run, millions.
Thank you very much.
Thank you.